And so next we have Rachel Wagner-Kaiser, Manager and NLP Data Scientist at KPMG, presenting Teaching Computers to Read, Natural Language Processing and Deep Learning Techniques for Parsing Documents. Rachel, just a reminder to start your timer and enjoy.
Sorry about that. Zoom wanted me to hit unmute before I shared my screen, apparently. Can you both hear me and see my screen now? Awesome, thank you. All right, thank you for that introduction, Claire. I'm excited to be here to talk with you all today. So as per the introduction, I work at KPMG, which is a consulting firm. So that pretty much means I work with a lot of different companies to help them solve their data science or machine learning problems. For the past about 2 years, I've been working in this particular space, working on how can we process documents and automate the reading of these documents to make our clients' lives easier. So I'm going to be talking a bit about the challenges in this process, as well as some of the techniques that we can use to get around or address those challenges. All right. So first, some business context and business motivation for this type of problem and this type of solution. So almost every single company has documents. It might be thousands of documents, millions of documents. It might be all sorts of different kinds of documents, whether that's contracts with different suppliers and services, or invoices like Wei Kun was discussing, or forms and purchase orders and all these sorts of different documents that they just have stored from years and years and years of doing business. And usually these are just sitting on a server somewhere. All the information in them is locked away in PDF or Word document form. But if companies have access to all the information that's in those documents, they can do a lot of things to help them save money, find new sources of income, or simply free up their resources to do more important things than reading documents all day. Because that's a very expensive and time-consuming process. And usually if you have humans reading documents all day, every day, you still only see a tiny percentage of the information in those documents. And so if you can automate this process, you can get information across all of your documents and use that to really look at your information at scale and make some better and more informed decisions about what your company is doing. So that's kind of the business context around this problem. But of course, it's not without its challenges. So there's a lot of variability that we see when we work with clients on these types of problems. One is simply the document type itself. Like I've already mentioned, in a single data set from a client that we're working with, we might find master service agreements, amendments, and addendums, and exhibits, and rate sheets, and invoices, and all of these different types of documents that we have to be able to process all together in a single integrated solution. Excuse me. So that's one type of variation that we see. Another type is simply the formatting of these documents. So usually each supplier that you work with might have a more or less standard format or outline that they use to draft their documents. But most companies work with thousands of suppliers. And so you're going to have a wide range of document formats, meaning the structure of the document, but also like things like the font and the headings and the point size, the margins, all these different types of things that you have to be able to account for in your final solution. And that kind of ties in with the document length and format, which also can vary quite a lot. You might see a 4-page master service agreement or a 400-page master service agreement, and the information in those two documents might be interspersed in different ways for otherwise the same type of document. Then there's the language itself, which can be quite complex as well. In English, there's 1,000 different ways to say the same thing. And so your solution has to be able to handle all of that variation in the language. Data labeling is also a challenge. Humans are not known for being particularly consistent in their annotations, even if you are working with subject matter experts. And it's still a time-consuming process for them as well. And the last point here is just rare information. There are some things that our clients want out of their documents, but they might be very, very rare, which makes it very difficult to find enough examples of that rare piece of information to build a good, robust, generalizable model. So these are just some of the challenges that we face in this sort of problem. And so I'm going to talk through some of the different areas that you can address these problems. But first I want to ground it in kind of a real example so that as we're talking through these different things, you can kind of think back to this example and how that might affect this example. So the example that I picked here is termination notice, which is pretty much how long you as a company have to tell the other party of the agreement that you want to cancel the agreement. So the information that our clients might be looking for in this termination notice clause is, for the first example, 60 days, second example, 30 days, and the last example, at any time. So you can see just based on this, the length of the information that you have to pull out varies in length. So 60 days and 30 days, that's 2 words and kind of like 3 words. And at any time is also 3 words. But you can have the information itself that you want to extract might vary in length. And then the context around it also varies as well. You have different language in each of these sentences. And then this is just part of a larger termination clause. So you could have a termination clause that's just a paragraph, or you could have like something crazy like this multi-part clause where the termination is just one little sentence in that whole thing. So there's a lot of variation here you can see just within this example. And then of course this clause could be anywhere in the document or maybe not in the document at all. So a lot of variation that we have to be able to handle all these different cases with a single model that is pulling this 30 days, 60 days out of this, this example. All right, so how can we actually go about addressing these challenges? And there are really 3 main areas that you can think of breaking it down. And you can address the variation in how you prepare the data. You can address the variation that you have to handle in how you create your training examples and your training and testing sets. And also in the machine learning side as well, like how do you create your feature matrix and what type of model architecture do you choose? So I'm going to talk a bit about each of these different areas. Starting with data preparation. So one of the biggest challenges that we see is most of the documents that we get on these types of projects are not machine readable. Machine readable documents are the ones where you can kind of go in and highlight the text and copy and paste it into something else. Most of the documents we see are like, older, they're scanned, they might be from the 80s or 90s and have really bad scan quality. There's wide variation in quality there. But usually, a small percentage are machine readable, and for all of the other documents, you have to do optical character recognition to pull the text out of that image of text into text that you can use and process and work with in whatever coding language you're using. So that process almost always introduces some kind of errors. So the example here, as a human, I know that the word natus, the last word in that example there, is supposed to be notice. But we have to go about this and teach the computer to understand that natus and notice are actually supposed to be the same thing. And so those 2 words aren't equal on face value to the computer. And so we have to use some techniques to teach it that actually those are the same word, even though one of them has a spelling error. So the other challenge that we often run into here is that we often see vocabulary that is specific to a particular industry, whether that's energy or finance. Finance documents have a lot of weird jargon in them. And it also might be legalese. And so you see words that you wouldn't necessarily see in any normal everyday context, but they're going to be plentiful in these documents that you're supposed to be automating the reading of. And so you have to account for that as well. And so thankfully, Wei Kuhn discussed this in the previous talk, but one great solution here is text embeddings. So fast text, as Wei Kuhn mentioned, is one package that allows you to retrain word embeddings to be customized to the data that you see. And so this helps to kind of smooth over some of the OCR errors because it learns that it sees the word natus and the word notice in very similar contexts. So they're going to have very similar word embedding similarities. And the same is true from the vocabulary, like the domain-specific vocabulary. The retraining of a word embedding model is going to learn to account for those words as well. So those are a great tool to help account for a lot of variability you see in the data preparation process. So another area is data curation. And my first point here is simply to not take a random sample. So if I think about a lot of the data sets that I've gotten from clients, usually like I said before, companies will work with thousands of suppliers, but they might have one main supplier. And so that one supplier might account for 50% of the documents that they have. And then the other 50% would be thousands and thousands of suppliers. So if you take a random sample, you're very much going to be overrepresenting one supplier, which might use just a standard template for everything. And so you're going to have 100 examples of that one supplier and 100 examples of like a few other suppliers. And so you're not really capturing all the variation that you're going to see in your data set if you just do a random sample. So one solution here is to stratify your sample. If you can, you don't always have the metadata to do that stratification efficiently, but if you do, that's a great choice. Another good option is to look at all your population and look for unique manifestations of the information that you want to extract. So for example, we're looking at termination clause across 1,000 documents, but we know that 500 of them have exactly the same language. Well, we're only going to take one example from those 500 and then pull examples from the other 500 that have more diverse language. And in that way, you don't overrepresent a language that you might see a lot, because the model will otherwise overtrain to that very specific language, and we don't want that. So you can automate that process to some extent, and this can be done pretty well by leveraging subject matter expertise. So working with subject matter experts, you might understand a few examples of the language you're looking for. You can use similarity metrics to look for other similar examples in other documents, or use keyword searching to kind of identify a bunch of candidates. And then you work with the subject matter experts to then label those candidates. It's like, yes, that's a good example. No, that's not a good example. And in that way, you're also saving the subject matter experts time, because they have to help you label the data. But rather than reading every document beginning to end, they're just looking at little snippets that you've pulled out and can easily help you label a lot more data that way. And then you can just use those unique examples that you found to make a very good representative data set that is looking at as much of the variation as you can capture. All right, so going back to rare fields, because I find this very interesting, I wanted to mention this. There are occasions where you're working on something and you might only find 10 examples of the language around the field that you're interested in extracting. Well, that causes problems, because if you only have 10 unique examples, you're not going to be able to build a very robust and generalizable model. So for rare fields, there's the option to do data augmentation. And there are a few different methods of data augmentation that you can use, and I've listed some of them here. So template substitution, for example, with the termination clause, we almost always see 30 or 60 days. But we don't want the model to learn that 30 days and 60 days always means termination notice. We want the model to learn to extract whatever the number and unit is there. And so with template substitution, we can go and pull out the 30 days and put in 3 months or 2 hours or 16 weeks, whatever unit and number that we want, to help the model have these kind of semi-synthetic examples to train the model with. And so that's the idea for data augmentation. Context permutation is switching around clauses or sentences. So same information, just in a different order. And that also creates these semi-synthetic examples for the data, for the model to work with. And then back translation is kind of a cool one developed by Google, where they take the original language, translate it to French or Spanish, and then translate it back to English. If you've ever done this on a translation engine, you know that it comes back mostly the same, but a little different. And so that helps to create these kind of semi-new examples for the model to train with as well. So one of the challenges with language processing is that you always have a variable length of text, whether that's the document length, the paragraph length, the sentence length. They're never going to be standard, but you need a standard size feature matrix to give to your model, right? So how do you go about doing that? And there's really two main ways to do it. One is to chunk the text. So you can just aggregate a feature or a feature matrix over a sentence or a paragraph or a page. And so that might be something like taking your embeddings at the word level and averaging them over your sentence. And so for each sentence, that's going to be an example for your model to train on. Another approach here is instead to use sliding windows. So say you're only going to look at 10 words at a time, and then you're always going to have that same 10-word size feature matrix to pass to your model. So again, it's standardized in a way that you can then feed it to the model. And in that case, with the sliding window, you can either aggregate over that window or use the individual features from each of the words in that window. And then this last step is just the machine learning architecture itself, which by the time you get to this point, you've already done 90% of the work. So the architecture is still important, but not as critical as all those steps before. So I just put a couple options here. Bi-directional LSTMs have long been used for this type of problem for information extraction. The bidirectionality means it reads the example that you give it both directions. And so it helps to kind of adjust for the fact in English, you can have context before or after the information you're looking for. And the LSTM is a version of a recurrent neural network that has a longer memory. So it helps to kind of connect information across a longer span of text than other normal RNNs would. And then BERT-like architectures are really up and coming these days, and they're extremely effective, although people aren't entirely sure why. But you have this encoder-decoder framework where you use a lot of neural networks to create a representation of the language and then decode that again to classify it. So these are really effective as well, but sometimes can be computationally expensive. So there's some trade-offs here. But just to wrap up, really the value in this whole process is to pull this information out of these documents in a way that would not otherwise be possible. So by automating this process, you are saving time and money for sure, but also helping your resources free up time so that they don't have to spend all day, every day reading documents, and they can instead do more important, more meaningful tasks. And by doing this, you also provide that information to decision makers who can use the information across these thousands or millions of documents to inform their decisions in the future and help their company do better. So that's it. I'm going to stop sharing my screen, and thank you all for listening. I will take questions. If I can find the question thing. Okay. Will text embeddings help when you want to do sentiment analysis, but in sentences instead of a specific word? So I guess if you're training your own sentiment analysis engine, then you could use text embeddings to do that. I think usually when people do sentiment analysis, they use one of the out-of-the-box models, like the Vader sentiment package, or you can use dictionary-based methods for sentiment analysis as well. But if you did want to train your own, you could try it with text embeddings. I can't say that's anything I've ever done, but that sounds interesting. All right. Do you have an intuition on the success rate of image-based document clustering versus text-based approaches? I'm guessing this is for document classification, maybe. I might need some more. Yes, okay, thank you. Yeah, that's a good question. I think for very text-heavy documents like contracts or amendments, having the text is extremely effective and not necessarily as helpful as just having the image of the page. But that said, for other documents like invoices, you don't have as much text to work with, and it tends to be easier then to use an image-based classifier. So I think it just depends on exactly what you're doing, which maybe doesn't help answer your question. But what additional challenges do we need to be aware of when dealing with non-English or multilingual documents? This is a great question. It's a huge challenge. So I worked with our Japanese colleagues to essentially do this process for their documents. The OCR engines, the NLP engines are not as advanced for most other languages compared to English. So it is extremely challenging. The OCR engine is not designed to handle the fact that you have one character that could be a word or a letter, as well as the fact that you have, in English, you only have, what is it, like 30, 40 characters. But in some of the other languages, you might have 1,000 characters, and it's harder to train a model to recognize such a wide variety of characters in some of these other languages. So it's extremely interesting and much more challenging problem than English. Let's see, beginner-friendly tools for someone with background in math, linguistics, and Python. Well, you probably already have all the background knowledge to make those packages yourself. So one that I use a lot is Spacey, which has a lot of good kind of standard out-of-the-box functionality for, part of speech tagging, NER. And so that's a good one. Another one is NLTK, that's really popular as well. And yeah, I don't know. Yeah, those are the main ones. There might be some more. I have to think a bit more about that. But good question.
All right, and this will be the last question, Rachel. Go ahead.
Okay, thank you, Claire.
Yeah.
So last question, which OCR library engine would you recommend to convert documents to text? I think the best open source one that I'm aware of is Tesseract, which is a Google project that they made open source a number of years ago. So open's free, it's relatively easy to install, it does a decent job. There are additional options, but they cost money. But there's some like Abby that have extremely high accuracy, but you know, they do cost money. But if you're looking for a good open source package, I'd suggest Tester. Okay, thank you, Claire.
Yeah, thank you, Rachel. Thanks for the great talk. All right, well, it is now time for networking and lunch. We encourage all of you to use this time for more one-on-one networking meetings. So just meet back in this track at 1:35 p.m.